Thank you everyone, and thanks for coming along. I think it's been a sort of meeting with a lot of seed emphasis, and Paul Gibson Roy highlighted, I think, some of the big issues on the way we need to think more creatively about seed, and I look forward to his presentation, and Todd Erickson's session yesterday about some of the great technologies that are developing. So I think we're in a great new journey, and it's one that we've really got to embrace fully if we're to meet the scale that's necessary. When you saw those figures from Linda's of the proportion of Tasmania that we're restoring, it's actually, I think, a national embarrassment, and so we need to move on that space. So I'm really here with one of the sponsors of this symposium, the INSR. Back in 2015 at the Native Seed Conference, a group of us got together. Alcohol's always a great fuel for getting people to agree to things, and we thought that there needed to be a common mechanism for dialoguing around the international needs of seed. And as we've heard from a number of speakers, seed, wherever you are in whatever part of the restoration spectrum, is a fundamental and important tool. So we all got together and decided, yep, this is something we'd like to do. We embedded it within SER, the parent organisation based out of Washington, simply so that we could get on with the business of networking and disseminating the science and the practice without the administrative load. And you're going to see some advantages to how that works. So if you're thinking of your own network in other ways, then think of this. It's really made life for us very simple indeed. So who are we? Well, you can go to our website. We're officially launched 2.5 years ago, so we're quite young, but as you'll see, it's grown in scale, purpose and reach around the world. We currently have around 420 members from 46 countries, and you can see we span a whole range of areas, and we've got our Mongolian colleagues coming on board. You can see the spread has a high dominance in North America. That's more a reflection of SER's membership being 80% US based. But I think, as Paul illustrated in his keynote this morning, they are actually in the really big end of the business of native seed use. So I think that's a horses for courses. Of course, the next big one, if you went to Simone Pedrini's talk, you'll understand that Europe is also big, particularly in the German space and a little bit more in the French space. So they really reflect where you've got a real vibrancy and leadership, often based on some deep time engagement by leading people and practitioners, and of course when you get the president of a country doing something positive and constructive and not being laughed at, then you can get great things such as is happening in North America. So what are we about and what do we do? So this really summarises, we identified the need for why seed is a fundamental and important part of the equation in restoring landscapes. We're a virtual network and we're international. So we appear at meetings and then we operate a virtual network with a whole lot of virtual opportunities. And with those 421 members that keep growing and that broad country sweep, it means we are touching upon lots of seed users and seed researchers around the world. So it's that virtual base that gives us the capacity to be very nimble in delivering this worldwide product. We aim to engage across the full spectrum, from understanding the pure science through to the end point, which is working with practitioners. And we want to develop a new subset of this group, which is working with Indigenous communities around the world, about developing Indigenous employment and Indigenous opportunities for engaging with landscapes. And our Brazilian colleagues are very well advanced, as we learnt last year at the Brazil SER meeting, in that whole space of Indigenous understanding and respect for those landscapes. Now, for any students in the audience, and please disseminate this, there's a real bonus. If you become a member of SER and you're within the Australasian section, we are offering 100 free student memberships, which means you go in, you quote that code, and you've got to be bona fide. We'll be looking at your picture and say, "They're a very old student. You should have finished a long time ago." And you will get free membership to SER. You then scroll across, you join the SERA chapter and then you check the box for INSR, or you can just check the box for INSR alone. You don't have to be part of the SERA family. And straight away you get all the benefits, discounts, the journal options, which include free subscription to Restoration Ecology, which is a real cash bonus for you. And you get all of the other information as you wish coming from that association. And there are a whole host of those, and some of those I'll illustrate in just a minute. This is our current team, and we keep growing, and it's a great team of mixed ages and across a broad spectrum. We do a whole lot of outputs. We are just publishing our latest newsletter. That should be out by the end of the week, and that's a quarterly publication. We promote all sorts of conferences that are both international and regional, and they're really useful ways of understanding what's going on. And you learn about current technologies and opportunities, and you can learn that through a whole lot of different things. Here are the conference areas, so you can go and look at the conference program or a calendar and find out where a topical seed-based meeting is happening in an area next to you. Now, a really big and important and growing area, and we want to encourage anyone here, and I'm going to be looking over at Todd's group to do the next webinar, but we have run a whole series of webinar programs. This is one that we did based on the German and European experience around native seed production, but there's a whole lot of others. And I did the first one, which was on smoke. So everything you want to know about smoke germination, but were too afraid to ask. There's already a webinar which steps you through all the processes. Global examples of best practices for basic things like seed collection, and Stephanie Frischke and a team of people ran that webinar, which has been really popular. And our latest one that went up is building your own portable after ripening bucket. So if you're in the heavy duty end of trying to understand some of the intricacies of how to get seed into a germination state, then that's really powerful. And this is a really simple tool, and we now know, based on that webinar, people are making their own after ripening bucket all over the world. So the webinars are an important and growing part, I think, of the service that we can provide, and it promotes your programs to a global audience, and then you can get feedback loops happening, and all sorts of sabbaticals can come from that. We also run a resource library that has a whole range of options, so you can log in there and find a whole series of different things that you might like. Importantly, you can contact us and we can connect you with particular people. So, for example, our Chinese colleagues wanted to know who else in China is a member, and so we're connecting up those national networks. So that's a powerful option. The other thing, and this is emerging and is actually, it's like our own version of Twitter, we have discussion forums. So I have an issue, I can't germinate a seed of this native flax species. You put that up and suddenly you find all these interesting people start connecting through with you. I found this, but I want to know how to solve that. You put that up, and it's a really fabulous forum for getting the most contemporary information that is available. And as the membership grows and the country reach grows, we're really keen to get more of that sort of dialogue, even if it's one-on-one or group-on-group interactions. It doesn't have to operate through the INSR banner, but just to get seed people talking to seed people. This is the other aspect. We have 44 partners. These are NGOs, government bodies, seed suppliers, seed users, seed producers, and that keeps growing on average by about 2 or 3 a month. So it's a broad group, Europe, US, Middle East, through the Kuwait Institute of Scientific Research, and as we move to different parts of the world, we try and garner new partners there. Now finally, a really big part of what our current work program is the building on the international standards for ecological restoration. We're constructing the first international standards for native seed, their collection, storage and use. This is going to have essays around seed written by definitive specialists in the field in these broad subject areas, but it will also have a standards section which hopefully will be the guiding principles to start developing national seed standard guidelines for the use of native seed. So that's a space to watch. Adam Cross and Olga Kildasheva from Chicago Botanic Garden are the coordinating editors, and there's 25 contributing authors to this issue. We expect possibly July 2019 once it's been through the full global consult. And we're calling ourselves the Seed Standards Reference Group. So that gives you a flavour of the sorts of things that are coming up in that space. So all I'll encourage you, it's simple, join today. An INSR member, if you are, excuse me, if you are not a student, is simply becoming a member of SER, and you go in and check the box and all those benefits flow. Thank you very much. Now it's my role to chair the rest of the session, and I think he goes after his magisterial presentation. That's what I best described it, statesman-like presentation this morning. I think we're very honoured to have Paul back with us to talk about the real nitty and gritty and to share with us what I think is an Australian leading example of what we need to think about in the scale of seed farming and production. Thank you.
Thanks, Kingsley. Kingsley came up to me looking all worried before this morning and said, I think there's only one slide coming up on your presentation. Are you okay? And I said, yeah, that was supposed to be it. He walked away even twice as scared. He was about half as scared as I was, but anyway. Look, this just really flows on. I think there's a bit of synchronicity going on here because Simon showed his talk about the European Seed Network. He and Kingsley have been co-authors on a seed survey of the European seed sector. Jackie Moore was talking about her trying to put together a survey around the US sector. So it's odd that at the same sort of time in different parts of the world, without actually knowledge, we're all doing this. We in Australia, and that group of people were the main drivers of this, forgive the pun on Martin's part, to try and understand a little bit more about our native seed sector. So this has been driven by the ANPC, the Australian Network for Plant Conservation. As a background, we really wanted to just try and put some parameters around getting some basic data on a range of sector-related subjects, including seed collection practices, seed use, the type of businesses that were operating, the different models. We wanted to throw out test some assumptions. You know, what did people think about certain issues? Explore relationships between collectors and buyers and those sorts of things. And we wanted to get feedback from people, from practitioners, from researchers, and we wanted to gather a bit more knowledge on how our sector operates. So the last major sort of survey, I guess we'd just say, would be the Mortlot survey back in the 90s, I think it was, and that was really focused on the planting sector. So the dynamics have changed a little since then. So I think it's timely that we did this. We conducted the survey, as I said, in late 2016 and into 2017. It was a web survey, so we sent this thing out, and it was a really comprehensive. So some of you in the room may have even filled it out. It took half an hour to 40 minutes to complete. So it really asked the respondent to give some time and information back. And, that was a risk, but we got some great information back on that. And essentially, I just put these here to try and give you a concept of how we broke up our sector. So essentially, we broke it into noting that there is crossover in these things, but we said, look, what most often defines your role. So even given that there may be some crossover. So it really fell out into seed collectors, seed growers, seed purchasers, and then we had a group which was other. So it was a lot of the people here. You might have been a student or a seed technician or working in a plant bank. So they're the way that the groups sort of fell out. I'm really just going to pick and choose a few things here. We're working on a report that's about 100 pages in length. So I've just thrown a few things here that I think may pique your interest. These are just the different respondents. So most of the people we got feedback were from collectors, less in terms of seed production, but again, that's a reasonably new phenomenon. Seed purchasers and seed others. to me, this wasn't a surprise because, again, I think there are more collectors out there proportionally than these other groups. And each of these groups represented, each of these single respondents represented organisations of, say, 5 to 10 people or purchases from 10 to 20. So even though we got a 40%, 48% response rate, which is very good for a survey, our overall survey response, I think, was approaching 160 or something. You could magnify that out to say that it represented a larger group of people from the sector, but it is impossible for us to know how accurately it represents the whole sector. This is such a difficult sector to pin down. So here's just a breakdown of the groups and where the respondents came from. So most came from New South Wales ACT, Victoria, WA, South Australia. Now, to some degree, again, even intuitively, these things play out a little in terms of you look at the economies, the markets that might be in those systems, and intuitively it sort of makes sense. No offence to Queenslanders or South Australians, but perhaps that's where more of the on-ground work is happening. It may not be, but there is a sort of a logic in that. We asked how people are affiliated, and it was interesting that just a few things from this. So seed collectors, seed growers, you can see here are primarily coming as private operators, whereas seed purchasers are primarily coming from state or local government. So again, this sort of marries into what we intuitively know, that most restoration is funded outside the mining sector and maybe offsets through publicly funded programs. So you start to get these sort of associations falling out in our data. The staffing characteristics, again, this is really interesting. I think it goes back to what Simon was saying about Europe to some degree, perhaps Germany aside. The bulk of the seed collectors, for example, are sole operators full-time, part-time, less than 5 people, 5 to 10 people. So their businesses are small. So obviously this market is not employing people that can put on, 20, 100 staff, like I spoke about it in the US. The same sort of thing for seed growers. Primarily, they're small operations. In terms of seed purchases, there are some coming in at this larger level. And again, they're probably working in government agencies, sectors like that. So they might be a part of a larger organisation, a team in it. We asked a whole bunch of questions. We threw these sort of comments out and asked people to rank them. And there was a scale from 0 to 5. So I've just thrown in the things that really ranked above, I think, 2.5. So 2.5 is, yeah, look, they're an issue, but they're not a big one. Up to 5 is, we think this is a critical issue. And these are pooled responses, and they've been weighted for the difference in the number of respondents in each group. But you can see there, and none of these things, again, are probably going to surprise anyone. But our sector is telling us that future demand for seed is going to be difficult to meet from the wild. That's a big issue to them. The market is unwilling to pay for the true cost of seed collection or seed production. There is a lack of seed available from a broad range of species. You can see how all these things are connecting and interconnecting. A lot of this stuff, it's all what we whinge about every time we get together in these things. It's just that this survey has put a formal sort of set of numbers around this stuff. None of this really surprises me to any degree. Now, in the report, we've really teased these things out, and I hope you really do take the time to read it when we launch this thing. When we broke the 3 main issues out across those groups, there was a difference. So for seed growers, the biggest issue for them is that they're not getting paid enough to do what they do. That seed orders are made at too short notice, and they're freaked out that future seed demand might not be met from the wild. Again, look at our landscapes. They're fragmented, they're genetically depauperate, they're inbreeding or whatever. People understand that, and that's one of their concerns. Seed growers, they're saying essentially you need us. That's what they're telling you, and that's a good thing. Seed purchasers, again, they're aware of these issues that are starting to loom, which I guess goes back to the thing I was talking about earlier today. We've got to provide a framework that supports all this sort of stuff. We asked people about seed usage, so what proportion of the different plant groups that they're actually using. And you can see here, so we've broken this down into trees, shrubs, grasses and wildflowers. The seed collectors primarily are collecting trees, shrubs, grasses, wildflowers. Again, This fits into the model of restoration at the moment, tree and shrub focus. The seed producers are not at the moment, they are doing it, but overwhelmingly they're producing grasses and wildflowers. In terms of seed purchases, so again, we know that they're mainly government agencies, mining of course in there, but again, trees and shrubs, grasses, wildflowers last. Seed origin, where does this come from? People are often worried about this. Where is our seed coming from? I think this is really interesting because there's a lot of fuss about we don't want collectors out there ruining our national parks. Most of the seed is coming from private properties or public reserves or public roadsides. Now, there's an implication for that because, again, we know these are the highly fragmented populations that are potentially not the ideal sources. Where the sources where potentially you've got big viable populations that you can take small amounts from to set up good production systems, the state and national parks, you're not really allowed on. Interesting stuff. The common usage ranges. This is a really interesting. All our talk about genetics and provenance and how far do we go. For a long time, we know in Australia that we've been banging on and on about local is best. Now, people like Linda and others have been trying to widen our thinking about these concepts, but it's still in many specs. I know specs in Sydney. I saw one about 3 weeks ago that stipulated a 5-kilometre boundary. So this stuff still happens. So we ask people to say, OK, where do you collect seed from? And purchasers, if you're buying seed for a project, how far away will you actually accept it from? Now, this is anonymous, so in some ways we probably got a better outcome by doing that. So this is just for trees. So you can see here, for seed collectors, let's just focus on those, very little, proportionally, is coming from what you would call local provenance. Most of it is coming from this generic below 50 kilometre sort of range. So your local sort of CMA or LLS or whatever you call them here. Here's the kicker, the really interesting thing. Look at all these other groupings. So these are all people that are collecting, and proportionally they're equal to this one, right up to and beyond 500 kilometres. And the same sort of thing to a lower proportion is for seed purchasers. So again, they're purchasing and using seed that's coming from 50 kilometres, but they're doing it from 100 and 200. Why is that? Maybe the seed just isn't available locally. We're saying it's coming locally, we're doing something else. The trend is remarkable. It's consistent across shrubs. So again, this same sort of, the bulk from 50, but there is a long tail out the back, both for collectors, but also purchasers. The grasses, the same sort of phenomenon. I mean, there is a difference across these things, but the pattern is the same. So, in essence, we're not collecting local. Well, this is what these people are telling us. We're collecting from sort of a wider local range and then some, quite a some. Usage quantities. This is an interesting one again. So we wanted to say from the respondent. So again, how this extrapolates to the whole sector is difficult to determine. But I think it shows us trends. That most of this tree seed collected, again, is in small quantities, less than 5 kilos, 10 kilos. There are very few people collecting on an annual basis large quantities of trees. And the same goes for purchasing. Most purchases are small quantities. Shrubs, same sort of thing. People are collecting small quantities. There are some people who are doing big stuff, and maybe this is the mining industry where there is a market for that. Grasses, same sort of deal. And here's the other thing. Look at all these things where what is being collected and what is being purchased. What is being collected, what is being purchased. What is collected, what is purchased. There is a difference. We are collecting and stockpiling seed. The market is not even buying the seed that we're actually collecting. And if you put parameters around all this and say, well, what's the midpoint of all these ranges by the number of peoples, you sum all those things up, and again, these just provide trends, but all up that totals to collected roughly 21 tonnes a year, purchased about 9 tonnes a year. This is bugger all. Now, even if that's out by a factor of 10, it's still not a lot of seed for the challenge that we're talking about. So there's lots of issues going on around here. We did some stuff on seed production, again, real snapshot stuff. What are the sort of growing systems that are typically used? So how much of a growing system is devoted to? They're mainly field crops. Our seed producers have mainly got field crops, so that's grass beds, shrub beds, then in-ground weed matted systems, and then containerised systems. In terms of size, most of our seed production areas are small, so we're starting here less than 2 hectares, less than 5 hectares, 1 to 5 hectares, 5 to 10, and then there are a few that are getting large. But again, nothing like what I saw in America or what probably happens in places like Germany or France. And the footprint, in terms of the breakdown of the seed producers that reply to us, overwhelming the seed producers are producing grasses. So that's probably the biggest market for plants that are being grown in seed production at the moment. I'm just finishing off now with a few issues that I think actually are relevant to places like this. So some of them relate directly to this. We got a whole lot of written responses in addition to these formal questions. And one of the things that was really hammered home by a lot of people, this issue around volunteer labour being disadvantaging the private sector. So land care groups, NGOs like the one I work for, getting public funding to build infrastructure, and then bringing in volunteers. Same could be said for Green Army, things like that, that underpin the private market. So in the Green Army instance, a lot of private operators in the region I work went out of business because the government funding stipulated the use of volunteerism. So our sector sees that as an issue. They also see as an issue, no offence to us, negative comments related to restoration-focused forums, which they think fail to meet the needs of practitioners. Now, I was really lovely seeing what you were talking about in the SER feedback and mechanism and network there, because I think that is a substantial step forward, because there is an issue. A lot of practitioners say that forums are run more for students and researchers to present their data, for agency staff to talk about their particular programs. They think that there's insufficient emphasis on providing practical advice to practitioners. Again, how do we make sense of all these varying genetic arguments? You know, often the geneticists are struggling to explain them. What hope have we got? So that's what they're saying to us in this sort of feedback. And the cost, again, it's no gripe, but a lot of us are here because we work for organisations where we're able to get funding to come. A lot of practitioners say they just can't afford to come to the places to interact with us. So again, what Kingsley's talking about, this virtual space, might provide a way. And again, the timing of the year. So again, there's some of the key findings. None of those will really surprise anyone. And what we hope to do and what we are doing is to try and really sort of focus on a set of recommendations. Again, for what I was talking about this morning, is to put more structure around what we do, so standards, frameworks, and Kingsley is working towards that. Seed strategy, regional seed strategy, stuff that are happening in the US and places like that, so that we can actually grow a sector which is at the moment arguably the best you could call it, a cottage industry, into something that was functional and capable enough to do the sort of things that we need to do. So please keep an eye out for the rest of this report. It's likely to be launched early next year, and this is just a taster of it. Thanks.
Thanks very much, Paul. We've just got 1 minute for one or two questions.
One or two questions.
I got one. Yeah. So, I'm familiar with the European situation, and the issue that we had there was the question that always been asked, so what is local? What do you consider to be local? And that's the reason why they created the boundaries and the areas in Germany, because they need to answer this very simple question for the legislation to say, so what defines you as a market that is different for what someone else is providing? When in Australia it's different because native species are native, but the concept of local, are you thinking in the space of creating some areas, or what are you thinking at that degree?
Look, from what I saw in the US, the seed transfer zones, and they also worked with a thing called ecoregions, which are again these sort of defined regions which take into account a whole range of morphological, altitude, all these sort of things to define collection boundaries. Now, to me, they work really well because they were big enough to support businesses, but also provided what the people over there think are ecologically viable populations and restorations. Now, I think we've somehow got to go down the path of seed transfer zones, ecoregions, whatever you want to call them. But the interesting thing about the survey, it says that people are sort of pushing out further. Now, whether they're going too far or not far enough, who knows? But without us defining these things, what at least the information we're getting back is that we're already going a long way beyond what most people think we are. That actually surprised me. I thought people were sticking to these sort of, local is best sort of things, broadly speaking, but overwhelmingly, people are not.
Yeah, Paul, just a real quick one. When you say less than 50 kilometres, less than 100, is it the band 50 to 100, or is it from 0 to 100 kilometres, the first point, in terms of when you're saying how far they're going?
Yeah.
So is it in the band of 50 to 100 kilometres, or is it from 0 to 100 kilometres?
No, it's 100 back to 0.
Okay. Second bit was there any comment around seed collection from restored landscapes?
We didn't get a lot of comment on it. No, that was actually...
That's a very good question, really, isn't it?
And we've got very little talk about that, but maybe that's a comment more around the lack of those sort of landscapes, at a grand scale. But most of the focus was on the concerns of the seed concerns around over-collection from the national estate.
And I guess the question is driven by the fact that we're going to our restored landscapes now because of the problem of finding seed, which is not local problems, so that's probably the space of growth as those areas becoming further from reduce.
Well, I think the main thing is that our restored landscapes have got to be genetically healthy and viable, which is what Linda and everyone is trying to sort of drive towards. And at that point, our restored landscapes become great collection sources in their own right. But we've got to make sure that we're getting that point, and as we know from what other speakers have said, the bulk of our restored sites are likely to be quite genetically important.
So the comment was Alcoa in Western Australia gets a lot of its seed from its own restored sites. One hopes that they've got the science to show that they're not depleting the resilience of the system by the sampling of the seed, but I think that would be quite simple to do. Great, thanks Paul, fabulous presentation. Now the next presenter, we change pitch a little bit, is Simone Pedrini. He's a PhD student on the CMSR project, which is a joint project between the University of Western Australia, Curtin University and Kings Park and Botanic Gardens, and has a whole range of industry sponsors. And Simon's going to today speak on some of the optimisation of seed coatings for native grasses. Thank you.
All right. Okay, thank you, Kingsley. So yes, as I said, optimisation of seed coating for native grasses. So the introduction is a bit redundant because already been said many times during this conference is how hard it is to deal with native seeds. Hard to collect, very challenging to process, tough to germinate, and if you try some seed production, it also can be very challenging. No surprise that because for these seeds tend to be quite high, and more often than not, as Paul just showed in his report, it's hard to find the seeds in the diversity and quantity that is required for landscape scale restoration. And usually once you get these seeds, I've seen happening both in Europe but also in Australia, is that once you got them, the way they are deployed in the landscape is usually by hand broadcasting or mechanical broadcasting, which results in lots of seed wastage. And even when more advanced techniques for sowing are used, there's still the problem of low establishment rates for these seeds. Usually, if you're lucky, you get 10% of your seed back in plants. In a way, we just need to get smarter in the way we use our native seeds. The approach I had taken to face this problem was looking into agriculture and see what has been developed by the crop industry to improve their performance. Remember, if you talk like canola or wheat, they're expected to germinate and emerge at about 95, 98%. So why we got so little? And one of the technology I worked on is seed coating. Seed coating is quite simple to explain. You just get a seed and you put some stuff around it. And there's three kinds of seed coating. One is film coating, where you just apply a thin layer of material around the seed. Then you got encrusting, when you bulk it up a bit, but the shape of the seed is still evident. And then you got seed pelleting, when you can no longer detect the original shape of the seed, and it looks more like a peel or a sphere. There's different reasons why this is performed. The main reason is to modify the shape, the size, the weight, the density of the seed in a way to make them more homogeneous and easier to handle and run through a mechanized system for sowing or for the logistic. And the other big reason is to use this artificial coating as a way to carry some beneficial compounds. The most commonly employed in agriculture are protectants like herbicide or pesticide, but you can add micronutrients, for example, or you can add soil adjuvants or phytopromoters. There's different range of technologies to perform seed coating. The three most common ones you can see here are reported in the industry as fluidized bed for film coating, rotostator and rotating pan for encrusting and pelleting. We have run a comprehensive review of the scientific literature and some of the major companies performing seed coating. What emerged was that in the scientific literature, more than half of the publication did not report the materials or method that they used, because the seed coating was outsourced to private companies. They would perform the coating, return the seed without telling what they've done, because it was trade secret. And this allows a big problem in the technology, that is this disconnect between industry and academia. Industry, the crop industry, is way ahead of academia, but they do not provide information, no protocols, they don't publish, so we don't know how to perform seed coating. So that's why, with some colleagues, we've developed this protocol development tool, which is like a practical tool that guides you step by step to perform seed coating on your own native seeds. And Khiraj is going to talk about this in the presentation after mine. So, going back to my project, I decided to work on 4 grass species that are very common in the temperate southern part of Australia, and are used for pasture, but also for vegetation and restoration. So the first question I have, does seed coating actually improve the handling? And to test that, I'll try through this small seeding machine. You can see on the left-hand side, we've got Microlinus typoides, or wallaby grass, run through this machine untreated, and on the right-hand side, I've got it coated. And you can simply see how much easier it is for the seeds to run through. And so after 10 meters of simulated sowing, this is the difference. So yes, the answer is yes, it does improve handling. But what about germination? We've tested germination, adding some germination adjuvants. And optimal condition, there was no difference. However, when tested at warmer condition and with low water potential and in the field, we saw quite commonly it was detrimental, the use of seed coating on seed. So what's the point of coating seeds if it doesn't let the seed germinate and emerge? So we had to go back and see what was done. And what was done on this species was to put the coat or encrusting on top of existing floret. And then start thinking, what if the combination of the floret and the coating is detrimental for the seed emergence? Why don't I just remove the floret altogether? The first thing to try, though, is to see if removing the floret has some effect on germination, which I did, and turned out that for 2 species, removing the floret was actually beneficial, so improved germination speed and final germination. But for 2 other species, it didn't have every significant effect, so it means that we can go ahead and clean those seeds to the caryopsis level. Other problem was that this is quite time-consuming, especially if you do it manually, so we want to look in a way to do it more effectively. So we tested 3 different methods. One is manual for control, flash flaming, and sulfuric acid digestion. At the scale we tried in the lab, the one that proved to be most time effective was acid digestion. And when we tested for germination, across the 4 species, acid digestion proved to be the best also in improving germination. So we decided to go ahead and clean our seed using the methods and then start to apply the coat. So we got clean seeds, we applied the coat, and then we tested again for germination. And at this stage, we can test lab germination in the lab in the first row. For 2 species, was actually improved when we put the coating on compared to the clean control, and it was improved in 1 case for emergence, while in the other case, there was no significant difference, no detriment. So it's a good sign that yes, probably the interaction between the floret and the coat was the problem. Removing the floret, now we can go ahead and do the coating. And now we know that, we try to put some extra stuff into the coating and use it to carry, for this case, a particular compound, which is aspirin, or well, the natural form of aspirin, salicylic acid. Salicylic acid is a plant hormone which is known to deliver stress resistance when it's given to the seed or the plant. It delivers resistance under abiotic stress condition. However, it's very rarely been tested on seed coating, and there's not clear effects of salicylic acid on germination of emergence. So the first question is, can salicylic acid be delivered through seed coating? And to do so, we compare seeds that were either imbibed in salicylic acid or encrusted with it. Then we want to check if salicylic acid does improve germination under optimal conditions in the lab or with reduced water availability, and also on the field to see germination and emergence in the field at same advantage for seeds with salicylic acid. And lastly, we want to see if salicylic acid improves survival and growth. So looking at the effects of salicylic acid on germination and emergence, we can see in this case, for Astrostypa and Retidosperma, usually there wasn't much difference, there wasn't much effect of it. It was a positive effect one time in Astrostypa and one time for Microlina, while it was detrimental the other times for Microlina. The reason for that is probably due to the amount of salicylic acid we've used. I've seen in the literature that salicylic acid does respond, so if we reduce the amount of salicylic acid, this might reduce this detrimental effect that we see here. And when we checked for the germination in the field and emergence in the field, we see for most of the cases that there's no difference, and one case was detrimental, probably for the same reason. So there was not a clear effect, sometimes positive, sometimes negative, usually neutral, but it's still up in the air if salicylic acid can improve germination and emergence, at least on these species. But then we went on and tested the survival. To test survival, we've done with two different experiments. The one you see on the left, we've got a plot which is alpha meter per side, and we've got 100 seeds sown in there. After 10 weeks, we remove all of the seedlings apart from 10 seedlings, which were spaced at least 5 centimeters apart in a way to remove competition between seedlings. The second experiment instead was sow 100 seeds on a line and then let them grow for 50 weeks without removing them from competition. So in both scenarios, with competition removed and with competition, we can see that in one case there was no clear effect, although there was still advantage of using salicylic acid, but was not significant. In all other cases, survival was improved using salicylic acid. And then we checked for growth as well in the plots where we actually removed competition, and we can see that in two species there was no clear effect of salicylic acid in growth, but for Microlina statoides there was a significant improvement both in height and dry biomass for the plants that were treated with salicylic acid. So growth was somehow improved, but not as much as survival. And also then we analyzed to see which was the best way of delivering salicylic acid. Was it through imbibition or was it through encrusting? And it turns out there's no significant difference, meaning that yes, seed coating can be used and does provide the same effect of imbibition to deliver salicylic acid. So to sum it all up, seed coating can improve seed handling, but the interaction of floret and seed coat is detrimental. Removing the floret does improve germination, and the best way to remove the floret, at least for this species, is the use of salicylic acid. Moreover, seed coating with salicylic acid improves plant survival. And remember, in this case, the improving survival might not be that great. We've improved probably 5%. But this is just using one active ingredient. You can actually put more stuff on that coating. If you've got problems of water repellency, like shown yesterday, then you can put some surfactant agents to solve the problem. You can put micronutrients. There's so many other things that could be loaded on the coat that could help improve those numbers. But then there's a natural question I usually get asked when I talk about this thing. Is it worth it? Isn't it too expensive to go through cleaning those seeds, coating those seeds, putting aspirates on those seeds? And the answer is probably a matter of scale. So if we grow up this market, if we really start using these seeds in the quantity we need, at that stage, yes, it's a big difference to have like a 10% success rate and a 30% success rate given the cost of this seed to start with. And with this ends my talk. If you got any question.
Very interesting. So the issue around getting them through the seeder,
Yeah.
that the seeding approach that you use is the traditional seeding sort of mechanism that we've always had trouble with grasses. Over here in the East States, we've developed a new type of seeding machine that will sow any species no matter what the attachment is. So that completely gets around the need to coat for the seeding equipment. So that's one thing aside, just to sort of let you know that. But the issue I have around this other stuff, around, say, improving germination outcomes with the acid or whatnot, there is so many questions now being asked of us around creating selection pressures, whether they're in wild harvest or in production and all these things. Are we just going down the same path in breaking dormancy, for example, or creating, you know, higher germination across a seed lot, when some of that seed lot might have an inherent, you know, sort of trait that held off germination for, you know, a certain set of conditions that we're not knowing about? So are we just, on one hand, saying don't over-select, but on another hand saying let's select?
Yeah, so I'll try to answer both the questions. So the first one about the equipment. I was aware of that equipment, so I was presenting this more in a general term. But still, I actually haven't seen it working. I'd love to see that. But what I've seen with some more advanced equipment they've used in Europe, even if you kind of overcome a bit these problems, improving the equipment or mixing it with something else to improve the flow, there's still a bit of difference that it's created in there because of the density of the seed. So especially if you've got seed mix, not single species, they always tend to separate based on the density of the seed. And this is something that seed coating could overcome a bit. But we can talk more about that, because as I say, I don't know that machine in detail, so maybe it does solve this problem. But the coating here is meant also as a way to deliver compounds. And grasses maybe are not the best example for improved logistic, but when you go in very tiny seeds, that's something Khiraj is working on. That's where you can get some real improvement out of pelleting. The other question was about the selection. That question is still up in the air. I had lots of discussion with people in the States about the same issue. So, what about the bed edging of a species to whenever the situation is there? But we need to remember that we are putting these seeds in a non-natural system. It's a degraded area, and in some situations we need to outperform the weed, so to have them germinate as quickly as we can in the first few weeks. So that's why we're pushing very hard at the beginning. But as I said, it depends on the environment, it depends on the restoration project. But having this tool in our toolkit can help us eventually work this detail around it. Because if you want to push them all at the first time, then we can do it. If you want to delay them, you can actually use seed coating that does exactly the same. So put seed coating that delays germination, and you can do that on some of your seeds and some on not. So it's just a matter of what we want and how we interpret those problems.
Right. So maybe you two connect up at afternoon tea break. Thank you, Simon.
Okay, yeah.
The next presenter in the series is Khiraj Bhalsing. He's commencing as a PhD student in the same centre as Simon, with all the same partner organisations. And Khiraj has a very interesting background. He actually comes from the dark side. He probably doesn't want me to say this, but he used to work for Syngenta, you know, the people that bring you GMO to your nearby farm and all of those things. But he then worked as a senior development person for Incotec, which was the major seed coating industry in India, so with a very, very large market indeed. And I think Australia's been very lucky to poach him to do a PhD on native seed coatings. Thank you very much, Khiraj.
Thank you, Kingsley. Well, my name is Khiraj. I'm originally from India. And as Kingsley told, my background in seed technology started with Syngenta. I moved on to Incotec. So yes, I do have quite a bit of an industrial background. So when I thought of shifting into native seeds last year, my initial reaction was that, okay, I've seen the impact of seed enhancement on the agriculture sector. If you see the seed enhancement market right now, it's almost 3.5 billion. And so my immediate reaction was that, why hasn't seed enhancement had a similar impact on native seeds? And I got thinking over it, and so I feel, okay, this could be a perfect adder for starting my PhD thesis, in which I'm now trying to develop a product form for native seed, which would help not only to improve seed handling and delivery, but also it would help in introducing a precision delivery of growth promoters and essential nutrients. So what I'm actually presenting today is a combined effort for the Center for Mine Site Restoration team towards a common goal of my thesis. And so here we present a first instance of a protocol development tool for seed coating. Now, in this slide, I was actually going to tell you quite a bit about seed coating and different types, but thanks to Simone, we have already went through most of it. But in this presentation, I would be mainly concentrating on encrusting and palleting. Of course, there are quite a bit of advantages, as we all have seen so far. And yes, this thing have also been covered. Why seed enhancement has quite a bit of problems if we introduce into native seeds. If I compare it with agricultural seeds, well, they have been working on it for quite a bit of ages. So they have a defined product form for each of the seeds. But if I compare it with native seeds, there is no empirical data at all available in this. And of course, there's quite a bit of knowledge gap, as we are aware, as the trade secrets are there, so they cannot share that knowledge. Considering that, right now the problem is we don't have enough empirical data. There is not enough of data shared by the companies, but it's not like there hasn't been any research done. Yes, there has been research done there, but very limited of it has been published. So considering the amount of data that we have published, what we know so far is that there are some machineries that we can use for the palleting or coating process. We have a list of published data for the fillers on binders that could be used. But the biggest knowledge gap that I found that wasn't or is never been filled so far is the methodology or the protocol for starting from a seed to reach to the palleted product form using the information that we have. And that is what we actually wanted to work. And we have been working for it for about 6 to 7 months. And finally, we were able to develop a first reported protocol development tool for seed encrusting and palleting. And it got published in July. When we were thinking of developing a protocol, we thought that the entire palleting or coating protocol could be divided into 6 different stages. And this is what we came up with. So each stage is kind of distinguished with different color. I'll be going through each and every step in detail. Well, the first step is, of course, general information of any operator who wants to do palleting. He can fill it a day in prior that, okay, I'm going to work with this species, I'm going to use different kind of binders and concentration. In this example, we used 2 different species. One, of course, is the agriculture species tomato that we use for palleting, and other is a native species micronus supporters that we use for encrusting. Regarding the raw materials, we used diatomaceous earth as a filler and cellulose powder as a binder. And for palleting instrument, we went with rotary coater, which is quite normally used and is a very precision palleting instrument. This is a setup that we had in our lab for our palleting trials, and this would give a general idea of the instruments or a normal setup anyone who wants to do palleting process should have. They should have the main instruments, of course, as the rotary coating machine, the scale, the drying, the dryer, the raw materials, and the seeds. I'll go through all of this in a bit more detail. Now, the work instruction that we have actually created, it is kind of work instruction that anyone can access and customize it according to their product form. So what is their final goal that they want? Do they want encrusting or do they want palleting? Now, the next step is, of course, just before coating, what you want to fill in there. What is the size of, what is the seed weight that you're using? What is the quantity of binder or powder that you're using? And this note over here, we have mentioned, it is useful to write down or to inform yourself that what is the final size of the product that you're looking for. Because, for example, if you have a seed which is 2.5 millimeter size, you need to know that what is the final pallet that you want to, what is the desired pallet size? Is it like 3 mm or 3.5 mm? So accordingly, you can manage your process. Plus, you need to also be aware of what is the size increment that you want. You do not want a seed batch of 1 kg at the end of the palleting being like 20, 25 kgs. You have to have a threshold over there. So that could be written down in here. Well, first step is the coating process, the main process. Well, it's quite complicated. It looks in here quite complicated, but I'll try to simplify it a bit to you. We divided the entire coating process into 3 different stages. In each stage, it's a kind of repetitive process in which in every stage we just add a binder, filler onto the seed using the palleting machine. Now, as you can see, we divided it into 3 different stages. In the first stage, the aim is to have a single layer of the material onto the seed. Now, this process is the most critical step because it's prone to having quite a bit of seed agglomerates or dead balls. By dead balls, I mean the material kind of forms very small balls without any seeds in it. So we want to avoid that, and which is why this process has to be conducted at a very slow and steady rate. Now, this is actually quite a manual process, so you have to add the materials by yourself. So at the end of every stage, you're prone to get like 3 different fractions. The fractions in which some of the seeds are like over-palleted, that are bigger than the size that you desire. Some of the seeds that are under-palleted, and the seeds that will reach to the desired size. So at the end of every stage, you have to sieve them out. So the under-palleted seeds will go back into the coating, and entire process will be repeated. And the over-palleted seeds can be just thrown away. And of course, the desired palleted seeds would be moving forward. So once you have a single layer around to the seed, we move on to the second stage where the process speed actually picks up a bit more, because as the seed already has a layer of powder along onto it, it's easy to build up on it. So the next process could be done a bit more faster, plus the amount of binder and filler you're adding in the per dosage could be increased. So this process could actually go 2 times faster than the earlier process. Again, at the end of the second stage, you have to sieve out the material. There will be some under-palleted, over-palleted seeds. And depending on what your requirement is, if you're looking for an encrusted seed, so at the end of the second stage, you should have a weight increment of almost 2 to 5 times of the initial seed weight that you started with. So if your aim is just to have encrusted seed, at the end of second stage, just sieve out the desired seed volume or desired seed size that you want, and keep on to drying. If you want to have encrusted product form, you repeat the step again until and unless you reach the desired size that you want. Now, this is an example of how the seeds look at each stage. This is a tomato seed. So at first stage, you can see you can have a uniform single layer around the seed. And the second stage, it got a bit, we got a higher volume on it. This is the encrusted product, and then if you want to have a nice round palette, you move on to the third stage. Now, as you see, at the end of each stage, you'll be having quite a bit of data generated. So all that data could be filled in the protocol development form, so which could be used later on to assess the entire process. The next stage is, of course, the wet phase, where at the end of your palleting, of course, you'll be getting 3 different fractions. One is the desired size that you want, the one that are under-palleted and the one that are over-palleted. You have to write down the fractions so you know how much of material has been utilized, which could be mentioned in here. And of course, the time has to be mentioned so that you know how much time it took for the palleting process. Next is the drying, where you put the seeds for drying at a specific temperature for specific duration, and you write down the weight of the dried product form. For our trials, we just use the food dehydrator, which is quite simple for us. And the last stage is, of course, the quality testing, where you have to test the final product form. Is it as per your requirements? The first quality testing that we did was the crust test, which is quite simple. From per lot, we took 10 to 20 seeds. We crushed them with the hand and see how many seeds are there per pallet. Are the pallets empty, or do you have more than 1 seeds in it? That will help you know how was the quality of your process. So accordingly, you can slow down the process or speed up the process. The second quality testing was a compression test, which kind of helps you to know the hardness of your pallet, because the pallets have to be hard enough to go through the logistical process. So that is why you need to check the pallet hardness. For that, we use a digital force gauge meter. Well, at the end of your entire palleting process and the QC, you'll be having quite a bit of data written down onto the table. But though you have so much data, you need to make some sense out of the data. For that, we have also attached an Excel sheet in which you can fill in all the data over here, or at each and every stage. And once you have entered data, when you go into the summary page, you'll be getting the results of your entire process. Results in the sense, what was the weight increment, how much of powder was used, how much of powder was lost, how much of binder was utilized, and what was the final weight increment that you got. So this Excel sheet will provide a final result of your entire palleting process. Well, these were the two seeds that we used, the tomato and microbial nustipoidus, and at each stage you can see the weight increment and the size increment. And thank you. Any questions?
Time for a question or two.
Yeah.
At what stage do other additions to the material, the pelleting process, go in?
I told you 3 different stages, right? So mainly depending on what you are adding, is it a contact fungicide or insecticide, whatever it is. During the second stage, you can load the chemicals onto the seed. I'll just show you a simple way. Over here, in the second stage, when you're adding it, it's like alternative process of adding binder and powders together. So once you have once you're at the half stage of your mark, you can add, if your chemical is in powder or liquid form, you can add a bit of it in the coating mixture, and at any time, at the middle stage, you can add it. But it depends on what you're adding.
Last question.
Thanks, Khiraj. It's good to see this sort of being put out in the literature to sort of step through the process. Have you mucked around with sort of the different sized batches and what sort of maximum you can do in this sort of current process? Because I can imagine if you're coating different sort of grammage or volumes worth of material, does that change up this whole process, and how would you capture that? And where else would you put the things, like if you wanted to add a surfactant, how do you put it into this sort of current protocol that you've outlined?
Yes, for the initial stage, we use the rotary coating machine, which is a lab scale. But right now, what I'm working is on upscaling the process in a pan coater. So in that, you can go from a batch size of almost 10 grams to 5 to 10 kgs. So we are right now, the protocol that we have developed, we are modifying it for the pan coater machine. So some of the steps could be excluded from this, and so we'll be developing a new protocol for the pan coater machine. So there'll be just some additions or deletions from this. And as you said, if it's going on pan coater, there won't be much difference in the steps or addition of chemicals or insecticide. It could be added at the second or third stage.
Thank you very much, Khiraj. That's all the time we have. Our last speaker, if Khiraj gets the next presentation up, is Michael Just. Michael's from Edith Cowan University in Western Australia. He cut his teeth in the world of seed working on one of the more difficult families that's Southern Hemisphere, Northern Hemisphere group, but lots of the Southern Hemisphere ones have big problems. I can see my friends from New Caledonia nodding profusely, and we're going to hear from Michael his research and his master's project about trying to solve some of those issues in Ericaceae. So good luck.
Cheers, Kingsley. What Kingsley didn't mention is I'm currently a PhD student at the Centre for Mindflat Restoration as well, based out of Curtin, with a lot of really good supervisors across both Curtin and Kings Park Science. A lot of the people I'll be talking about through this presentation are my current supervisors, so it's really cool that I've fallen where I have. So this is a project that began back in 2015, as Kingsley said, a part of my master's, out of Edith Cowan University, but funded by the Wildflower Society of Western Australia. They're a really good non-for-profit group that propagate a lot of native Western Australian plants by seeds, and they, particularly their Coolin branch, which is in the wheat belt of Western Australia, was interested in how do we actually get some of these species into, they were primarily concerned with their gardens and whatnot, because they don't tend to do too well from cuttings. So they gave the money to ECU and they passed it down onto me, and we had a look at it. So the Ericaceae are a pretty fascinating group. They've got about 4,400 species distributed globally in almost every imaginable climate. Here in Australia, they are in one of the largest subfamilies, the Epacrodoideae, and in Western Australia they fall primarily within the Styphiliae, which is the largest tribe within that subfamily. They have around 350 species. But why look at them? So the Ericaceae form a dominant portion of understory vegetation in much of Western Australia. They produce quite beautiful, unique, long-lived flowers, and they also have quite a bit of threatened status. About 125 of those 350 species have some form of status, be it rare, threatened, endangered, what might have it. They're also incredibly difficult to germinate from seed, and that's really where the problem lies. This was kind of identified in the late 90s by people like Shauna Roach and Kingsley Dixon, and they were kind of left there. Research on them was few and far between. Less than 5% of this family in Western Australia actually has a presence within the literature, and this was the case up until about 2009, where people like Shane Turner and the team out of Kings Park picked up Astroloma xerophyllum and made some headway there, and my work throughout my master's kind of builds on some of the stuff that they discovered. And this whole thing sits in kind of a broader context of what we call intractable species, or species that are difficult to work with at some stage. So this is something that I've taken, I took 24 families identified as containing species with intractable seeds from a paper Dave Merritt produced in 2007. Basically looked at the number of taxa within each of the Ivory RA regions that occur in Western Australia, and compared that to how many of those species have been identified as intractable. And as you can see, it comes out at about 30% across the board. So a large number of species within Western Australia are considered intractable, and this might be at the seed collection phase, the storage, germination phase, seedling phase, whatever it might be, but at some point they're quite difficult. And so this kind of research at the smaller scale slowly ticks away and builds up to kind of ease the use of some of these species, and that's kind of where my PhD work at the moment sits in. So this kind of took us all over the southwest of Western Australia and a little bit into the wheat belt. So as I mentioned, Coolin branch sits right about here, which is the reason we've got a site all the way up there. They really wanted species from their local area, and we compromised by selecting species that occur both around the Perth region and the Coolin region. And these are the species that we targeted. So the real problems within the Ericaceae fall mainly within the Drupaceous Ericaceae that form this woody fruit contained within a various form of mesocarp and exocarp. And you also have what's called a dehiscent capsule that opens to release numerous small seeds. So we selected 2 species of those. Just something to note, it's been a little bit of a pain in my site, is that this whole family is undergoing quite a bit of revision. The entirety of Astroloma is being reclassified into Styphelia, and about 108 species in Leucopogon, not this one. So just when I'm saying Astroloma, they will at some point be some form of Styphelia. So the first thing we really did was quantify and look at the morphology of the seed and reproductive material of these species. Partly to help with the reclassification, but also to just get this information out there for people who, like myself, might be going out to collect some of these species and not quite knowing what they're looking for, so it's good to have out there. So here you can see the fruiting body of Andersonia heterophylla and the numerous seeds in their various viable and non-viable states. Looking at it a bit closer, you can see that fruiting structure actually opens along midlines upon dehiscence to release 4 to 5 seeds. The average is 4, and 5 locular. And the seeds are actually quite interesting in structure. This differs quite a bit from Lysinium pentopetalum, which forms this longer capsule. This one was taken at immaturity just to quantify how many seeds are actually in there, because as they open, these seeds release quite quickly. And again, you can see the type of seeds there. Moving on to the Drupaceous Ericaceae that we looked at, there's quite a bit of variation in the form, and this is what we call a multilocular uniovate endocarp, meaning that within these structures can be, in some cases, up to 7 seeds, sometimes as low as 3. And so the first thing we really wanted to do when just redefining or defining dormancy in these species, as a lot of the initial work occurred before the currently recognised dormancy classification system, was just look at do they take up water, which is a sign of do they possess physical dormancy. So we used 2 methods here, one for capsular species, which is a basic imbibition graph, and yes, they did. The other one was to do moisture content, pre and post imbibition, and we actually drew a little bit on some of Mark Uwe's work and just used a visual inspection to make sure that some of the water was getting in there. And this kind of thing's been done again by Shane Turner, and Karen Shea did it as well to show that These large endocarps restrict a bit of water, but in times of higher soil moisture it does get into the seed, so no, they are not physically dormant. We also wanted to define the embryo, so this is an indicator of morphological dormancy in these species. So you basically measure seed length and compare it to embryo length, which gives you an ES ratio, which will tell you if the seeds are dispersed with immature embryos. For both capsular species, you can see the embryo runs the full length of the seed is developed, morphological dormancy does not occur. For our drupaceous species, ES ratios range from about 0.2 to 0.5, which is a good indicator of morphological dormancy in these species. We were also able to confirm quite significant growth in all species prior to germination, for the few that we could get to germinate, which is again another determinant of that these species do possess morphological dormancy. We also had a bit of a closer look at the endocarp structure, mean locule number, mean seed number, and how many of these fruits actually possess more than one seed, which can be considered as kind of endocarp viability. And these were done on the X-ray machines up at Kings Park. I'll draw your attention down here. So this is a bit different to this. As you can see, it's a bit more translucent. And when you break open the endocarps of Cordyceps and pendulum, what you actually find is they act as a larval host species for a native species of WA wasp, a chalcidoid wasp, also known as a fig wasp, in the genus Megadostigmus. A big thank you to Brian Hederick at the WA Museum for helping me key these guys out. We got it down to genus and they gave up. We were pretty confident they were represented in the museum collection, and I wasn't in this for bugs, although this is quite interesting. So we found that for the population that we assessed, these guys occurred in about 50% of endocarps. They reduced mean seed number from about 1.44 to about 0.7, so it's quite significant. We also observed them in 3 populations separated by about 50 kilometres. Our initial hypothesis, based on a bunch of in situ findings of endocarps like this, was that they used their mouthparts to chew a hole out and escape. Looking back at this, I had a subset of endocarps still sitting around 2 years later. Started opening them up, hadn't noticed a single emergence event over the 2 years that I had them, and we found this consistently dead wasps. So in ex situ seed storage, endocarps don't degrade, and I hypothesise that these guys don't possess the ability to actually break out without that natural soil storage. And that actually has a bit of interest when we start talking about what you actually have to start doing to these fruits to get them to germinate. So before I get into that, I'll talk a little bit about the germination of capsula-seeded species. So this is one of the first things we did, was just test a range of treatments to determine if these seeds possess physiological dormancy and what form of dormancy that physiological dormancy that might be. Control and cold strap didn't do anything, that's expected. Gibberellic acid had a result which has indicated that they possess some form of non-deep physiological dormancy, quite a significant result in Lysonema and less in Andersonia. The most interesting thing here is this, that we got no response to smoke. So Lysonema pentapetalum was originally Lysonema ciliatum, which was subdivided, and this is one of the species that Kingsley, Dixon and Shauna Roach identified as being very smoke responsive in their earlier work. Whether they used fresh or aged seeds, I'm not quite sure at this point. I should probably have just asked him. But so what we did here was use fresh seed, and we also used a commercially available smoke product called Smoke Master Region, which, unknown to me at the time, actually has a bit of a reputation for being rather toxic and just generally not good. It's produced from lignin, and it's just not what you want. So we went back and looked at it again with Smoke Master Region and chemically available and homemade smoke water from Kings Park. And I used seed that I collected during my masters and seed that I went out and recollected at fresh state. And what you see is that the original results hold up, controls don't germinate, and fresh seeds with Smoke Master Region don't germinate. But this result shows that there is a degree of after ripening that occurs in these species. Time in soil dry, time in soil dormancy releases, and seeds can respond to smoke. There's also a small response of fresh seed to smoke, showing that not 100% of seeds are released dormant, and that smoke water can promote germination, but Region cannot. Moving on to our drupaceous Ericaceae, and this is where most of the interest lies. I'll show you the good graph, I won't show you the bad one. Within endocarps, over all the treatments I tried, over 540 days, I didn't get a single germination from within an endocarp, and it was a very depressing year and a half checking these incubators every other day and just nothing. When we take them out of the fruits, though, you get this really significant germination. Nothing in Conostephium minus or pendulum, and this is only after 30 days. If you'd moved them to cooler germination temperatures, you might have gotten something. And as you can see, gibberellic acid is the most significant that controls, and smoke also produced, and that is regen there, actually produced quite a significant result as well, which shows us that these seeds have morphological dormancy. They also have some form of physiological dormancy imposed by a mechanical or chemical restraint of the endocarp, which over time in soil is progressively broken down, and these guys are able to germinate. And this holds significance when we look back to our little megastigmus wasps, and I know we didn't get these to germinate, but assuming the natural processes would allow them to germinate once that endocarp breaks down. So there's some kind of mutualistic relationship between this wasp and germination. Whether it helps the endocarp break open or whether it does so naturally releasing the wasp is unknown. It does require a bit further research, a bit more work research. And just to kind of hone in on the actual mechanism here, we, again, taking on some of the work that Shane did with Astroloma, we took whole endocarps and incubated them in 100% oxygen for about 3 months. As Shane showed this work for Astroloma, we also got it to work for Chrominia and Leucopogum, and quite significant in Leucopogum, as you can see there. So the mode of action here is up for debate. Higher oxygen might have facilitated a greater oxidization of chemical compounds within the endocarp that restrict germination. This process occurs naturally in soil and we just sped it up. Greater oxygen may have also permeated the endocarps, giving rise to greater metabolism, which actually let these guys alleviate any physiological dormancy and actually break out of the endocarp sooner. So just to sum it all up, Drupaceous species possess morphophysiological dormancy or morphological dormancy with a mechanical aspect of physiological dormancy, if you want to get technical. Capsule species possess physiological dormancy. Ex situ germination of both groups is possible in a short time frame, but it's incredibly labour intensive and nobody should be subjected to getting those seeds out of those fruits. All study species require further research quite a bit. Mechanisation of endocarp removal should be a priority in these species if you want to get them into natural systems, and I know the great team at Kings Park has been looking at this. The effective soil storage and after ripening on all species should be a priority. Also temperature optima and smoke and all the other things, just to find out what exactly is going on in these systems. And also the role and interaction of Conostephium pendulum and megastigmus wasps in the ecosystem. Conostephium is buzz pollinated by bees. Whether it's pollinated by these wasps, I can't say. But if you're talking about restoration and bringing these species back into the environment, if you don't have this or vice versa, is this going to be a functionally active species or is it just going to fade out? That's me. Thank you to the CNSR for supporting me.